Hello, thanks for joining us today for our Estimating Heart Axis with EKG Electrode Placement webinar. In a few moments, I'll pass it over to John and Sarah, and they'll do an introduction to the EKG and electrode placement experiment and go over some of our other options, including a demonstration of graphical analysis pro. So I'll pass it over to you guys.
Hi, my name is John Melville. I am the Director of Biology at Vernier Software and Technology. I have a bachelor's degree in biology and psychology from Sonoma State University. I got my PhD in zoology at Oregon State University, and I did a postdoctoral fellowship at University of Oregon. But the most important thing, oh, sorry, the poll questions are here. I'll wait for the poll questions, and then I'll come back and introduce myself. So why don't you answer the poll questions first? What grade level do you teach, high school, college, or other? And then are you here to learn more about the EKG and electrode placement experiment, or do you want to learn more about Graphical Analysis Pro? So go ahead and do that. It will take a few minutes for the poll to happen, and then I'll come back to introducing myself. Thank you, Angie. And then Angie, when the poll's done, why don't you let me know how many people, like what the focus was there, and then I'll go back into introducing myself.
It was high school and more interested in the experiment itself.
Oh, cool. Great. That's terrific. So I'll back up there and just say, yeah, I've got some degrees. I've got a PhD. I did a postdoctoral fellowship. But the most important thing actually is that I'm a former educator. I like to say that Vernier is for teachers by teachers. So I am a former college professor. I used to teach both majors and non-majors courses in biology and neuroscience, marine biology, and my focus was on active learning. So doing experiments with a focus on data collection and lots of inquiry and research methods. And I've taught, human physiology, animal physiology, things like that. And then I will now, you can meet Sarah. Sarah, do you want me to introduce you, or do you want to introduce yourself? I can introduce you, or
I can introduce myself. My name is Sarah Tolarovic, and I am also a PhD in zoology from Oregon State. I did a postdoc in neuroscience at the University of Texas in neuroendocrinology. And also, very much like John, I was a professor of biology. I taught for 15 years at the college level, and I taught everything from intro biology for majors and non-majors, lots and lots of human anatomy and physiology, animal physiology labs, neuroscience, endocrine, everything. So, and I also am a big advocate for active learning and for inquiry-led learning and research for students.
Cool. And what we were going to do is, just wanted to let you know, is ask all your questions in the Q&A. Sarah will probably be there answering your questions, or others as we go, if time allows. She may let you know that it's going to be answered live, and what that means is that she's going to take that question and toss it to me, or her and I will answer it in this actual webinar. The other thing that you probably are going to want to do is, if you don't have graphical analysis, go to our website or go to the Chrome store, iOS store, whatever you want, and download it. And just make sure that it's the latest version. But we might be past 5.4. Let me take a look. Yeah, sorry, we're on 5.11. So I will have to update that slide. We're on actually 5.11, and no sensors are necessary. What I'm going to do is we're going to start off with talking about EKGs, how to get an EKG, and then how to estimate the heart axis and what the heart axis is. And we're going to be using the Go Direct EKG. That's this sensor over here, and graphical analysis. Just a little bit about the Go Direct EKG. Let me just show you a little picture of it here. Here is the EKG sensor, the Go Direct EKG sensor. What's really nice about the Go Direct EKG sensor is it's a little box. It doesn't require an interface. It can be connected via USB cable, or it can also be connected via Bluetooth. So that's this little indicator here would be for Bluetooth. This little indicator here means USB, and this just means the battery's charging. And one of the nice things to know about it is if it's plugged in, it's ready to go. You don't need to, it doesn't need to have a charge to actually work. All right, so once again, I said Vernier software is for teachers by teachers. We're gonna do, I'm gonna collect some EKG traces, and then we're gonna do a live demo of Graphical Analysis Pro. And we're just gonna do several things. I wanted to let you know that the EKG sensor is also good for other things. In addition to measuring EKGs, estimating heart axis, you can look at heart rate. There's a heart rate channel, and you can also use it to study EMGs. So you can also study muscles.
John, I wanted to interrupt for just a moment and let Angie know that, thank you, Michelle, for letting us know that the link apparently, oh, Angie's already fixing it. Fantastic. I was going to say the link that we had in there was for the wrong lab. So Angie has dropped a new one into the chat for this lab today. Thank you, Angie, for taking care of that.
Thank you, Angie. Yeah, they're in the folder. Well, we'll go through that. There should be the lab. There's actually the instructor's notes, and there should be some sample data, which I'll show you how to use as well. So what we're going to do first is I'm just going to show you how to record data. Graphical Analysis Pro has 3 different ways that you can collect data. The classic one would just be collecting data straight into graphical analysis. It has a really cool, that's this model right here, in-person learning is what we call it. There's also a really cool way to do remote learning via data share or send it just to the internet. We'll demonstrate that. And then there's also videos that actually live in GA Pro, and I can demonstrate those to you as well, like how you could do this whole lab, or you could show a video with the data in it and create an activity that you could then push out to students and they could open it and view it. Okay, so let's just ask, I want to ask you a couple questions, get things going here in the chat. Is to understand heart axis or what the heart axis is, the first thing to do is to understand what are the components of an EKG trace and what is happening. So can anyone tell me what these 3 events mean? So what is happening during a P wave, during a QRS wave, and during the T wave? Feel free to just throw that in chat. Just let me know. Because these 3 electrical events, this is an EKG trace, we're recording an EKG trace. Normally when we would do an EKG lab, or we would introduce students to the concept of an EKG, these electrical events refer to things that are happening to the heart. The P wave refers to the atria depolarizing. The QRS wave is the ventricles depolarizing. And the T wave is the repolarization of the ventricles. So the important thing to think about here is when we're going to be looking at heart axis is we're going to be focusing on the QRS complex, or this big tall spike is called the R wave. The entire complex with both negative deflections is called the QRS complex. And remember, the QRS complex refers to what is happening during the ventricles. And normally, if you were doing an EKG trace, that's like what you would do. In our EKG lab analyzing heart EKG, you record an EKG, and the students actually calculate heart rate, and then they look at the different components of that of the EKG, and then link those to different events that are happening in the heart, both the time difference between like the P and QRS, and also just where they are and what they're responsible for. Now, if you were doing a clinical EKG, there's lots more leads that you would record with. So if you were to go to a doctor that would actually wanted to look at your heart, or a cardiologist, they would do several lead EKGs. In this diagram here, we're just showing you 3 leads. 3 leads basically means that they're recording from different positions. And what they can do is they can look at what we call the heart axis, which you can think of as, remember I was talking about the ventricles. Remember, here's the bottom part of the heart. Here's the ventricles, pardon me. Here's the atria. So when the ventricles contract, they produce that really big EKG trace, the really big spike. If the leads the lead that is closest to the tip of the ventricle is going to have the largest EKG trace. So normally when they're doing a lead axis, what they're trying to figure out is what's going on in different regions of the heart. And we can estimate heart axis by looking at the maximum R wave amplitude. Now, just so you know, the normal electrical axis is between -30 to 90 degrees in the shaded area. And remember, this is what you're seeing is a mirror image. So this over here is the left side, this over here is the right side of the heart. Now, our EKG sensor, the Go Direct EKG sensor, is what we call a single lead. So you can't do 3 leads simultaneously, but you can just rotate the lead configuration to do that. And that's what I'm going to demonstrate. So in the basic lead configuration, the green lead is negative, red is positive. You ground to your foot, and then you just rotate these leads. Then the second trace, you record green is still on the right hand. Red is then moved down here to the left foot. And then the last one, here we rotate the green lead and the red lead stays down here. Any other questions? All this lab really is rotating leads and recording EKG traces. So if you've done the analog EKG lab before, you typically start out in the lead 1 configuration, only you just ground to your arm because you're just recording across the heart. And then we're just going to move through these different leads. And once again, what we're looking for is the maximum, which lead trace has the maximum R wave amplitude. So once again, this is the R wave. So we're going to be recording 3 different EKG traces, and we're going to be looking at which one has the largest amplitude. And just to reiterate here, if the maximum R wave is with lead 1, then the heart is at about 0 degrees. If the maximum R wave is at lead 2, then the axis of the heart is at 60 degrees. And if the maximum R wave is at lead 3, then the axis is approximately 120 degrees horizontal and your left. And to just show you a diagram of that, so if the highest, largest wave is lead 1, that's at 0 degrees. If the largest QRS, largest R wave is at lead 2, that's 60 degrees. And if it's the largest one is at lead 3, then that's 120. Now, the other thing to be aware of is this is the positive. So it's the tallest positive deflection. All right, so the next thing I'm gonna do is I'm just gonna record an EKG trace. Are there any questions before I do that? No questions?
John, how precise are these?
These aren't precise, right? Because all that we're doing is really estimating. If you were trying to do that, this isn't something that should be used for clinical purposes or anything like that. It's just giving you the general location. That's why we say it approximates and we can estimate where the heart axis would be. You know, a real clinical EKG trace has, I believe, 12 leads, and there's lots more information that's there. So these devices are not used for medical purposes. If you have students that are concerned about their EKG trace or anything like that, they should be referred to a physician or a cardiologist. This is just to show that the size and amplitude of the EKG trace changes as you move the leads, to sort of show students why you would do a 3-lead EKG. Other questions? All right, so I'm going to launch GA. Hopefully you can see that here. And let me just make move this into presentation mode a little bit more. Get it a little bit bigger. There you go. And let me get the video here connected. So what I'm going to do is, you can see that I already have these 2 leads attached here. And then I'm not going to show you my foot, but I actually have an EKG on my foot, or not an EKG, I actually have an electrode tab on my foot. So those two leads. So we will go back here and I will record. Oh, and I've already just plugged it in over USB. It's actually probably going to be quieter, less noise if I were to plug it in or use Bluetooth. And I can show you how to use Bluetooth if you would like as well. So red, green, and then black goes on my foot. Pardon me while I move my foot up. All right, so let's go back to GA. So now I'm going to sit quietly and let's record an EKG trace. Let's just do one more. I'm going to do file new. And what's really nice about when if the EKG trace, if the EKG sensor is just plugged in over USB, you can just do file new and record again. So there we go. There we go. So that's lead one. Let's go back. Okay, lead two. So for lead two, what I'm going to do is I'm going to move. Here we go. Here's lead one. Red, green, black. Oh, okay. I just need to move the red lead to my foot. And just exchange the red and black leads. So I'm going to do that. So red goes to my foot. So now you can see, I hope you can see green, green, black, and then red is on my foot. Let's go back to graphical analysis. I will sit quietly and collect data. And you can see the R wave is, QRS wave is much smaller, like a lot smaller. Any questions so far? Then I'm just going to go and rotate one more time. Go to lead three, and in lead three, let's see, black goes to right. Green switches over to left. And then I will collect again. I'll try to be quiet here. There we go. Oh. So now what I'm going to do is I'm just going to remove these electrodes and let's talk about what we see here. Let's do a couple of things. I've got 3 different data sets. Let's see here, data set 1, data set 2, and data set 3. You know what? I'm gonna let's make these color coded. I'm gonna make data set 1 red. Let's make data set 2 green. So all I'm doing is I'm clicking on the y-axis and then actually selecting the color, and then we'll make the third one blue. And then just so that we can be clear here, I'm going to go over to the top right corner, click on the data table, and I'm just going to label these. I'm going to say, hey, data set 1. Oh, it's getting a little slow there. Reset data set 1, rename it lead 1 or lead 1. Let's label data set 2 lead 2. And then let's label data set 3 lead 3. Great. And then I'm gonna, let's get rid of the data table. And then I can actually click on the bottom left-hand corner and turn on the graph legend. And there, see there, now you can actually see it quite clearly. Lead 1, lead 2, lead 3. So for my heart, is my heart closest to 0? Or is it closest to the, you should be able to see that the greatest amplitude of the R wave is right here, right? That's lead 1. And that it decreases quite a bit at lead 2, and it's actually negative, right? It's actually negative for lead 3. So if we go back and take a look at that, well, the maximum R wave is lead 1, then my heart is approximately at 0 degrees horizontal from the left. That's approximate. So that means my heart is tilted up a little bit over here. Questions? Any questions at all? Like, I can send you this data and you can analyze it. That would be our next step if you have any questions. What you will see, and I think it's really interesting, Sarah wrote this lab. This lab is actually from Human Physiology Experiments Volume 2, which is considered our advanced book. And her heart axis is different than mine. Typically her heart axis, if I remember, Sarah, let me know, but I thought it was my lead 1 gives me the biggest R wave. Your R wave is highest at lead 2. And we've measured other people that actually have completely reversed. So, and that doesn't mean there's anything wrong. It's just, you can get a lot of variability from students. And just because we would assume that lead 2 would, for most people, might give you the biggest R wave, that doesn't mean there's anything wrong with it. It's actually really interesting to see how this changes with different students. Did you have anything to add there, Sarah?
Yeah, mine is so when we did the lab to play with this prep, mine came out at the estimate being 60 degrees. What's kind of interesting is I have actually had a diagnostic EKG done since then. And of course they did I think it was a 12 lead, so lots of data. And when I got my report back, I checked, I thought, oh, how close are we? And I think my actual heart axis is more like 58, 59, but I thought it was really cool that it's like really close to the 60 that we estimated. So again, not, ours is not diagnostic, but it does get you in the ballpark of estimating roughly where the heart axis is on a subject.
Yeah, and there actually are other really interesting conditions that people have too that can invert this. So what is it? There's situs inversus, and then what's the other one, Sarah, where if it's just the heart?
There's a condition where the heart can be reversed, which is called dextrocardia. And then in that scenario, you would expect like totally the opposite pattern. Like when you reverse the EKG, reverse the lead, you would expect to see the largest in the third position, but even more so. In fact, this with our 3 leads, it would actually not be a great way to detect that. But it might make a normal EKG look possibly inverted. But that's a very rare condition. I think it's 1 in 12,000 people have situs inversus, is where the organs in the body are reversed. And dextrocardia specifically refers to the heart being reversed from the typical pattern.
And what's great is if you were to if you want other data, Sarah and I have put our data, actually, don't tell anybody it's our data, but it is our data, actually in the example data. So if you were to buy the Human Physiology book, or there is sample data that's provided, or in our sample data library, there's 2 versions of sample data. There's sample data that shows it being different. So you can actually see from subject 1 to subject 2, there is a different in heart axis. And I can even show you how to open that data, take a look at it if you want. But we can share this data really quick if you would like. There's this really cool feature in GA Pro. So let's go back here to GA Pro. And if any of you have GA, or you can actually create a temporary Pro license by putting in this number, NWHULAJSB. I will show you how to do that in a moment, and that will make it the Pro version. So if we go back here, let me just that here's graphical analysis. And there's this little TIE fighter icon here, which I can use to data share. So hold on. If I go to about, or if you go to about, you can update your license key. And you're going to want to put in there this N capital W H U L capital A J capital S B. And by doing that, you will get a version of GA Pro that will last for about 2 weeks. And so if you want to, I would definitely try doing that. Check that out. What I'm going to do, let's see, hold on, there's a chat question. Oh, great, thank you, Angie. What I was going to do next is just show you how to actually share this data. So here is this data right here. I'm going to start a session where I'm going to share this. And then the code that I need access to, or that you could use, is PRV4YR. So once again, that's PRV4YR. And I will show you why that's important in a minute. I have a Chromebook in this room. Pardon me. And this Chromebook is on the same network. And what I'm going to do is I am going to start a new session of graphical analysis. And I am going to choose data sharing. And then I am just going to type in that code. And that code, once again, was PRV4YR. PRV4YR. Just make sure there's no spelling. Yep. Okay, there we go. Then I'm going to connect. I will connect. And there we go. The data has been sent wirelessly to my Chromebook. And you can send that anywhere that there is internet. Let's see, there's a question. Oh, there we go. That's just giving you the code. Does anybody have any questions? This is a really, really powerful tool. So that if you are teaching in class, you could actually grab data. You could data share it out to everybody that's there. Students don't have to download data, open up data, export it, all of that. So it's really simple to use. If you have students that are working remotely, you could have students that are in class collecting data, and then if they're remotely or they've been quarantined, they could log in, get on the internet, and you can send this data to them. So questions about data sharing? Let me give everybody some time to do that themselves. Let me know if you can actually get some data sharing done. Did you get the data?
So John, from the student viewpoint, the student would want to launch the app and make sure that they're running the GA Pro version, correct?
Yes. The student has to do this. Yeah, the student has to do the same thing. As if the student gets started, I'll start over here really quick. Oh, so the student, let's see here. So the student would have to do the same thing. When they get started, they probably will only have to do this once, but when they first launch graphical analysis, they'll need to put the code in here as well, the GA Pro code. Once they submit it, then they have all the GA Pro options, and then they will be able to share data or get the data. The main thing is that if you're the instructor, you click up here on the TIE Fighter icon and begin a data sharing session. What the students have to do is when they launch graphical analysis, I'll just start over. They want to pick data sharing. So they would actually pick data sharing instead of sensor data collection. They would pick data sharing, and then they would type in the source code that is present.
And
And
does
once
that
again,
source code change from session to session?
it should change from session to session, yes. So if someone else is doing a session, that the source code will be different. PRV4YR. Oh, I'm typing it in the wrong place. PRV4YR. There you go. Questions? All right. Let's see, let me move this out of the way.
If a school wanted to try this out a little longer, John, where would they find it? Is there a longer trial available?
Yeah, there's a 30-day trial that they can use that you can get a hold of. I can take you to the website where you can sign up for that. So if you go here and go into products, you can actually go to software. And you'll be able to find GA Pro here. Complete with pricing. And there's a free trial. One of the things to be aware of is you need to actually tap on this tab for free trial, and then you can sign up for a free trial. And that'll last for 30 days. The one that I gave you will last for 2 weeks, so you could use that now for 2 weeks if you wanted to. And the K through 12 pricing is different than it is for college. And once again, this lab is actually from our new lab book. Human Physiology with Vernier. So there's Human Physiology Experiments Volume 2 and Human Physiology Experiments 1. Human Physiology Experiments 2 has more of the advanced labs in it, but it's still used, and it also uses our blood pressure sensor and our spirometer. You can take a look at the table of contents here. And we are actually doing lab number 5, EKG and electrode position. Then there's a bunch of other lab activities that are in it, including like biofeedback, advanced analysis of EMGs, and other things. Other questions on GA Pro? Graphical analysis. I can show you how to insert a video. Before I do that, why don't I show you a couple of things that most teachers think are really important to take a look at here in GA. And that's, hold on here. Let me bring GA to the front. Hold on. So one of the really nice things of graphical analysis, just to let you know, is you can interact with the y-axis here. So if you interact with the axes, oh, that's AirServer. Let me just get rid of that for now. And hold on. Minimize this. That's interesting. It went away. Hold on. Let me grab some data for you here. It's just interesting. Let me close GA. go. I'm just going to close that window. I'll close this. Thank you for your patience, and I'll relaunch it. There we go. And what I'll do in this case is I'm just going to open up some of the sample data that we have. So let's see, there's subject. Well, that's okay. But don't need that right now. So I just unplugged it. So you can see here's the same data that I collected. So it's a little bit cleaner. And you could still see the same thing for lead 1 is bigger than lead 2, lead 3. If you wanted to actually see all 3 graphs, there's a great way to do that. You could tap on the top right-hand corner and you would just select 3 graphs instead of 1 graph. So we were originally looking at 1 graph, lead 1, lead 2, lead 3, and we could turn all those on. Or you can go up here and you can say, hey, look at 3 graphs. So you can look at them all at the same time. And you can still see that lead 1 is the most positive in my case, or has the biggest spike, or has the biggest R wave. If there's great ways to export data. So if you wanted to export this graph, you can go here to export. And you can easily export the graph. It's going to show you all 3 graphs that you can export. So you could easily import these in, save these as PNGs, or export them as CSVs. And so you can get them straight into Google Docs if you wanted to, or anything like that. Questions?
We don't have any in the chat.
All right, so then what
actually,
I'll do.
One of our attendees, let's see, did our attendee raise their hand? Michelle, if you want to put a question into either the Q&A or the chat, feel free. Looked like we had a raised hand icon.
Gotcha. I mean, I can share this data too. What I'll do next, let me wait to see if you have a question there. I was just going to show you how the videos work in GA Pro 2, and then I can give you another tour of some other features. There's lots of really nice advanced features here for the EKG traces. I could even trigger off of a level and show them all coming at the same time. Any questions there? No?
All right, I haven't seen any questions appear.
All right, so let's just say I'm gonna start over here. And let's just say that you had a student that didn't make it to class. You could create your own video with an EKG tracer. You could take this data and put it in there. We have some preset experiments. So if you go in and say see experiments, we have some experiments that are already listed. Here's monitoring EKG. This is from biology with Vernier, but you could create your own, and I can show you how to record data here. Let's see, let's wait for it to launch. Oh, there's a question.
Yeah, it's a question about the software purchase. She thought the GoDirect included the software necessary.
Yes, so let's go back and we can definitely discuss that. Let me just close that really quick. So if what you want to do is just record data, you don't need to do anything else, right? So if you wanted to do this lab, all that you have to do is get graphical analysis.
Which is free.
Which is totally
free.
The
basic version is free.
The basic version is free. You can record data into it. You could do this entire lab with your students without buying Graphical Analysis Pro. Anybody can get Vernier Graphical Analysis. You just go to our website. And then there's a download for Windows. There's a download for Mac. You can get it from Web Store. There's a version for iOS. There's a version for even Google Android devices. So there is no requirement that you buy GA Pro. You could have your students do this entire lab. All that you would need is the instructions from the book and the Go Direct EKG. I mean, you also could do it with our older EKG as well. You would need an interface, but there's nothing that would stop you from being able to do the entire lab. It's just the GA Pro features, what they do is they make it so that you can share data. So you can push data out over the internet, and or you can have videos attached and things like that. There's also some really cool other advanced features that you would want GA Pro to have if you were going to be doing like analyzing EMGs. But you don't need anything else. If you get the sensors, the software that you need to use them is free. GA Pro is just a really cool feature that we have that we developed for remote learning. Another thing that you might want to be aware of that I can show you. Oh yeah, well, yes. So the question was, so we'll be able to compare the data, not share it. Well, technically you could still share it, just not share it as easily. Right, so you could record the data. Students could record the data. You could have that data file and they could save it and they could email it to each other. It's just a lot easier if you wanted to do it like in real time. Like I could actually start up GA Pro, put on the electrodes, have you all connect to a session, and the data would come across while I'm recording it. The other really nice thing is once the data has been exported, it's in their format, right? Like if any of you logged on and got that data, like I still have it on my Chromebook. Let me show you here. Here's the data that I recorded. It's still sitting on my Chromebook. It's still live. Even though I don't have that old file and closed it, all that data is still here. So students can independently analyze data as well. The one thing that you have to be careful of if you actually have students that collected data and then they pushed out to other students is you just want to make sure they make a copy, right? So it doesn't get written over. But yeah, this feature called data sharing is only available in the Pro version, specifically over the internet. Other questions? Those are all great questions, by the way. Please ask more. If you have any questions, that's great. I will minimize AirServer. Any other questions? No?
Not at the moment.
All right, so let me open up graphical analysis again. And let's just say you wanted to, let's see, take a look at an experiment. Oh, there is a question. Oh, yeah, sure, no problem. Okay, so let's take a look at this monitoring EKG experiment again. That's odd. I don't know why it didn't open up. Might be taking a long time to load there. I will have to double check that. There are videos that exist in GA Pro. Interesting. I'll have to see why that's not working. But what you can do is there are experiments that live in it. What's actually pretty interesting is if you have the Pro version, there is a way to insert video. So if I turn the video icon on, you can actually import video, and there's actually a way to sync a video to the data as well. So I could actually import a video of a person doing an EKG trace. Like you could film it, and I could have the data in here live, and then you could push that experiment out to students, and they would be able to see it all. Other questions? Another cool thing that I should show you, just so you can see that the data is probably better over Bluetooth using an EKG trace is, hold on here. And the reason that has all to do with this idea of what we call noise. So let me turn on the camera here. So So here is the Go Direct EKG. I'm going to press on this button right here. Now you should be able to see a little flashing icon. That flashing icon says the Bluetooth is actually broadcasting. So what I'm going to do now is I am going to connect the leads. So I'm just going to connect these leads to myself. Oh, connect to my foot, pardon me. Thank you. Great, and then let's just do file new experiment. By the way, file new experiment is your friend. If you ever want to start anything over again, start from the beginning. It's great. So I have not plugged in, if you take a look over here, the EKG sensor is not plugged in. There's the USB port. I have not attached it to USB. It's just sitting here. The leads are attached. And what I'm going to do next is I am going to connect. So if you take a look here where it says GDX-EKG, there's a number right here. That number is right there. So each one of these sensors has a unique identifier. That way they don't get lost, or students don't get confused. There is a proximity connect feature, so I could put this literally right on my computer and hit proximity connect, and it'll connect, but I'm just going to hit connect right here. And then what's great is you'll see different sensor channels. There's EKG, heart rate, EMG rectified, and a voltage channel so that you can look at the raw signal. The reason why I like using it on Bluetooth is I can hold it in my hands. It's not connected to any other devices, and get it away from all the lights, and we should see a cleaner EKG. The only issue is I have to tap stuff, but let's just see what it looks like here. I'll sit real quiet. There, so hopefully you should be able to see that this is a nice cleaner EKG trace than what we saw previously. There's a little bit of noise, but it's a lot cleaner. So that's just another way to collect data. So there's the EKG sensor again. I'll minimize that, maximize that. And then I could rotate leads again here. And we could, record data, and it would look a lot cleaner. Other questions? Questions about the book? Questions about graphical analysis? Questions about the sensor itself, the Go Direct EKG? Questions about data sharing? Has everybody done an EKG trace before? Have you ever had any problems with it? I can tell you the few minutes I've got left, all of my little key tricks. The key tricks that I use is that if you noticed, you didn't see me put the EKG tabs on. You also noticed that my EKG tabs are on my wrist. That's not super critical where they are, but an important thing to know is that if you place them closer, if you place them up higher, like up on the biceps, you get a much stronger signal typically. So if you're having problems with an EKG trace, you can move them up to the biceps there. I like to put the EKG tabs on early. That way it allows the solution that's in the EKG tabs to sort of integrate with your skin, and you get a lot better signal. So what I tend to do is I'll put the EKG tabs on real quick. Then I'll wait a few minutes while I'm talking before I do a demonstration, and then I will connect them. The other thing to notice is if you take a look at these, hold on there. Yeah, it'll be available on our website. Terrific. If you take a look at these tabs, they're clip-on tabs. So they're actually clipped on to these little leads right here. And it's important that you not move around. So you need to sit quietly, not move. If you want to get a good EKG trace. There are other EKG tabs that are out there that actually have snaps. Those snaps are great. You could get those if you wanted to. They're more expensive. And then what you would do is you would just attach the little alligator clip to the snap. These EKG tabs are not reusable. So you can't like take them off and then reuse them again. And then the last thing that I would add is that there is a link, should be a link in the folder of just a bunch of things that you can do with EKG traces, like help for you to get connected to if you wish. So other questions? So yeah, if you chat right there. No, any tabs will work. So what I wanted to show you here is I have a bunch of links to EKG videos and tutorials that we have that you can just get to. And that's in the folder that you should be into. No, these are not specific for, I mean, the reason why we use our tabs is because they're very affordable, right? A package of like 100, I believe is incredibly affordable. So we know that money can be an issue. So we try to get the most affordable ones there. They work great. The snap-on EKG tabs, they work like they're very, very stable, less prone to noise. They work really well, but you're going to pay more like $20 for 50 or something like that. Another thing that I tell people to do sometimes is if you know anybody that's working at a hospital, now is probably not a good time to ask them for a favor. But typically what I would tell people is if you know anybody that's working at a hospital, they probably have EKG tabs that they're going to throw out because they expire, and they'll be fine for you as an educator. They probably won't be a problem. Some of our EKG tabs that we have here that I've used before have been around for years. They do degrade over time, so don't expect them to work perfect if they're several years old, but you know, it's just really affordable to have the EKG tabs that we have, but other EKG tabs will work great. Other questions?
John, do you recommend any type of skin prep prior to placing the tabs?
No, but you can. It's a really good thing that you do bring up is that I have like really good skin conductivity. Like I get EKG traces to work on me all the time. There is a small percentage of students and or people that it'll be hard to get a good EKG trace on. The best thing to do in that case is to test another subject, because the likelihood is that another subject is going to be fine or move them up. You can use abrasive gels and stuff like that, or definitely clean off the skin with soap and water. That's a good thing, but then just make sure you dry it off before you apply the tabs. I don't have to do anything to my skin, but there are preps that you could use to do so. Other questions? The one thing I like about both these labs is they're very fast. I mean, you can record an EKG in 3 seconds, and you know, you could do this whole lab like we did in a very short period of time. Another really interesting thing you could do if you wanted to that I could show you is there's a nice advanced feature in GA. Let's see here. I could collect data on a triggering event. So I could also say, okay, well, you know, let's trigger data at 0.5, which is about the heart height of a QRS complex. And let's collect 20 data points before. I can hit done. And now when I hit collect, you can see that it triggered right about there, and I captured all of the data points before. That can just really be useful if you're doing something and you want to make sure that all of these are aligned, all of the EKG traces. So you can trigger off events too. Other questions? Issues? It's actually quite an affordable sensor as well for what it does. Let's just take a look at it here really quick. EKG would help. There we go. Go Direct EKG. Yeah, it's $169. In a lot of cases for a system that'll record EKG, sometimes you pay $1,000. So Sarah and I have worked really, really hard to make this sensor do what it does. We're actually very proud of how well that it works. There's a lot of work that went into making it work for all the parameters that it can be used for. And if you have any questions, you can always email biology@vernier.com, and that'll get to one of the three biologists at Vernier. If you want a physiologist, just say, hey, I'd like to talk to a physiologist. If you want to get in touch with me, just say, hey, I have a question for Melville. If you have a question for Sarah, you could say, hey, I have a question for Sarah, but you can just email biology@vernier.com and those will get to us. Let me go back to the end of our demo. So once again, if you have any questions, you go to the Vernier website. You can always call us at 1-888-837-6437. We have email support, we have chat support, and you can also email the biology team at biology@vernier.com. So with that, I think we'll close the floor unless you have any other questions.
Thanks for attending today, everybody.